AlphaKoala here again. Gonna get that third question down. Okay, the third question reads as such. Attempting to stop on a slippery road, a car moving at 80 kilometers per hour, so we'll write that in, velocity initial equals 80 kilometers per hour, skids across the road at a 30 degree angle to its initial motion, coming to a stop in 3.3 seconds. So it was originally going this direction, which we will label as the x-axis, and we should put our y-axis up here. That was the initial direction, okay? But it's going 30 degrees to its initial direction, right? The answer wants us to answer meters per second, so we have to convert everything to meters per second. To convert to meters per second, we times by 1,000 to turn kilometers into meters, and divide by 3,600 to turn hours into seconds. An easy way to remember this is just 80 over 3.6, which is going to give us 22.2 meters per second. So we'll put that in. That's a pretty good number. Okay, now what we're going to have to do is, because we're trying to find out its acceleration when it's stopping. So since it's slowing down, it's actually going to be a deceleration or, a negative acceleration, depending on how you want to think of it. But we'll think of it as deceleration. Alright, so to find how much it's decelerating, we need to find out, so acceleration equals final take initial over time, which is just changing velocity over time, which is a formula everyone should be familiar with at this point. Now, its initial velocity we can work out by using our cos. Now it's supposed to be a dotted line. Just make that dotted. That's beautiful. Now, we can work out initial velocity by using the opposite. Opposite equals hypotenuse times sine theta equals 22.2 times sine 30 degrees, which gives us 11.11 meters per second. So that's going to be 11.11 meters per second. And as you can see, it's going up, so it's going to be positive. Yeah. And our adjacent is going to equal, let me just do this a bit shorter than the other one, 22 times cos 30 degrees, and that is going to give us 19.24 25 meters per second. And we'll put that in. And once again, that's going to be positive, so it's going along the positive x-axis. Now, what about its final velocity? Well, it says that the car came to a stop, so its final velocity is going to be 0 in each direction. So we'll put its initial velocity inside, 19.25, 11.11, and its final is going to be 0, 0, equals final. Okay, so we know it's final, subtract the initial. Now, if we got 0 subtracting a number, it's just going to give the negative that number, because 0 take 19.25, it's just going to give us negative 2.5. So we know that the change in velocity is going to equal negative 19.25 and negative 11.11. And, that's pretty good, but that doesn't give us our acceleration, because we need time. Now, in the question, the time was given to us as 3.3 seconds. Since we're using meters per second for our calculations, that is already in the correct unit, so there's no conversion needed. So just go time equals 3.3, we'll say, 3.3. Therefore, and we want to sort of do these individually, because this is going to be in the x direction. I actually said I was going to use i's and j's this video, which I forgot to do. I'll just chuck them in now. So j is that direction, I is that direction. So basically, the opposite was going up, so that's going to have a j, and the j is equal to 1 meters per second upwards, and the I is equal to 1 meters per second sideways. So I won't have to write meters per second, I'll just write j. And for you, I can just write I. Bit of a curly I, but yeah. So that would be I, that would be j. So I've just kind of brought the I down with it. Sorry about that, I did promise last video I'd use i's and j's. In this video I got a little ahead of myself and kind of forgot to do that. Okay, so put them in here as well. So our acceleration in the x direction, so acceleration in the x direction, is going to equal the change in velocity in the x direction, which is negative 19.25, over our time, which is 3.3. And our acceleration in the y direction is going to equal, that should be I, is going to equal negative 11.11 j over 3.3. If you don't know that i's and j's don't worry too much, they're pretty important, but they're not that complicated. I just kind of forgot to go over them, and that's my fault. So I'll probably go over them in a later video, and, I'm sorry. Negative 19.25 divided by 3.3, if we just put that in, 19.25 divided by 3.3, that's going to give us negative 5.8 I, and that is going to give us 11.11 divided by 3.3 is going to be negative 3.367 J. So if we kind of look at it, that kind of makes sense because it was originally going with a positive velocity and it's kind of slowed down. So it makes sense that the acceleration in each direction would actually be negative, because if it was a positive acceleration, obviously it would actually just be going faster, not slowing down. So it makes sense that they'd be negative at an intuitive level. So we know that this is in meters per second because of the I, and we know that that's in the x direction because, they kind of line up quite nicely. So we can put it down here as negative 5, meters per second squared, actually. So that actually won't have the I's. Sorry. Yeah, that's going to confuse a lot of people, and I really apologize for that. But acceleration is always in seconds squared. Okay, sorry about that. So 5.8 is going to be our acceleration in the x distance, negative 5.8, and negative 3.3, and we'll round up 2 places, so negative 3.4 is going to be our acceleration in the y direction. And that is the question, so we'll just break it down what we did. We worked out that to get acceleration, we're going to need the final velocity, the initial velocity, and the time. The time was given to us. The final velocity equals 0, so we only had to work out the initial velocity. The initial velocity was 22.2 meters per second at 30 degrees, so we broke that down into its vectors using the height rule. Then we used final subtract initial to get the change in velocity, remembering, of course, that acceleration equals change in velocity over time. So once we had the change in velocity, we divided that by time. So the change in so AdX was going to equal a change in velocity in the x direction over time, which equals negative 5.8. So acceleration in x direction is negative 5.8 meters per second squared. And the acceleration in the y direction is going to equal the change in velocity in the y direction, negative 11.11 over time, which equals negative 3.367 meters per second squared. You always arrange your answer in the form of x, y. It's just convention. There's no real special meaning to it, but it is expected that that is how you will answer. So we put our x in there, our y in there. We're using 2 significant figures because that's what the question asked for, and our question is done. Next video I'll be talking about some concepts and to do with circular motion. Alright.